Cutting of metals. The cutting edge of tool perpendicular to direction tool travel. The cutting forces occur two directions of only. In a orthogonal cutting, in depth of cut halved and feed rate is doubled. The chip thickness ratio is unaffected with the changed cutting conditions. The actual chip thickness will be doubled. In oblique cutting of a metals, the cutting edge of a tool is inclined at an angle less than 90 degrees of the direction of tool travel. Discontinuous chips are formed during machines of brittle material. The ductile material during machining produces either A and C. Continuous chips with built-up edge are formed during machining of ductile metals. The factor responsible for the formation of discontinuous chips is low cutting speed and small rake angle. The high cutting speed and large rake angle of the tool will result in the formation of continuous chips. The factor of responsible for the formation of continuous chips with the built-up edge is dash low cutting speed and small rake angle. In continuous chip cutting, the maximum heat is taken by cutting tool is no. In continuous chip cutting is the maximum heat the velocity of cutting is that depends upon. The continuous chips are in the form of long coils having the same thickness throughout is agree. In oblique cutting system, the maximum chip thickness is may not occur at the middle. In oblique cutting system, the cutting edge of the tool is the may not clear the width of the workpiece. Which of the following statement is the correct for orthogonal cutting system is all of the above. In orthogonal cutting system, the maximum chip thickness occurs at the middle is the correct. Which of the following parameters govern the value of shear angle continuous chip formation is all of this. Which of the following statement is correct for oblique cutting system is all of the above. In oblique cutting system, the tool may or not generate surface parallel to the workpiece is yes. In oblique cutting system, the maximum chip thickness occurs in the middle is wrong. The addition of lead sulfur and phosphorus low carbon steels helps to dash all of this above. In determining the various forces on the chip merchant assumed that the all of this above. Cast iron during machining produces discontinuous chips. Mild steel during a machining produces chips is continuous. When the cutting edge of the tool is dull, the during machining is the continuous chips with built up edge are formed. If the cutting speed of increases, then the built up edges become smaller and finally does not form at all. In a metal cutting operation, the shear angle is the angle made by the shear plane with the direction of tool travel. In a metal cutting, use of low feeds the high cutting speeds desired when the objective is the surface finish. The velocity of tool relative to the workpiece is known as the cutting velocity true. The velocity of tool along tool face is known as chip velocity. The shear velocity is the velocity of none of these above. The vector sum of cutting velocity and chip velocity and the shear velocity equal to. In a metal cutting operation, chips is formed due to plastic deformation of the metal is agree. Segment chips are formed during machining is the cast iron. In a metal machining zone is where the maximum heat is generated due to the plastic deformation metal is called a shear zone. In the metal machining, the zone where the heat is generated due to the friction between the moving chip and tool face is called as friction zone. The material which of the machining produces chips with built up edge is the ductile material. In a metal machining, the work tool contact zone is zone where heat is generated due to dash burn and the burnishing friction. A dynamometer is a device used for measurement of forces during metal cutting. The type of tool used lathe, shaper and planer is the single point cutting tool. The type of tool used milling machine and broaching machine is the multi-point cutting tool. A single point tool has dash all of this above. The part of tool which edge of the formed is called is wrong. The angle between the shear plane and is called a shear angle is work surface. The angle made by the face of the tool and plane parallel to the base of cutting tool is called as rake angle. The angle between the face flank a single point of cutting tool is known as lip angle. The lip angle is the dash between tool face the ground end surface of flank. The angle between the face of the tool and the tangent to the machined surface at the cutting point is called a cutting angle is correct. The angle on which the strength of tool depends upon the rake angle. The lip angle of a single point tool is usually 60 degrees to 80 degrees. Carbide tipped tool usually have negative rake angle. The rake angle required to machine brass by the high speed to 0 degrees. The negative rakes is usually provided in a cemented carbide tool. A single point thread cutting tool should ideally have 0 rake angle. Which of the following statements is correct about notch radius is both A and B? It improves tool life, it improves surface finish. A American standard applications of ASA system, the tool nomenclature 8655 10 15 2 mm, then the side rake angle will be 6 degrees. Cemented carbide tool are generally poor in shear is yes. A cemented carbide tool tips are produced powder metallurgy true. The current sequence tool material is increasing order of their ability of retain hot hardness is the dash. Ceramic carbide, ceramic borogen. The binding material used cemented carbide tool has the cobalt. The rate of moving metal is by increasing the depth of its cut increases. The side relief angle of single point of tool in the dash between the surface of the flank immediately below the point, a plane at right angles to the center lines of the point tool. And in a single point tool, the angle between the surface flank immediately below the point line drawn from the perpendicular to the base is known as end relief angle. Back rake angle single point tool and by the force tool is inclined towards back is agree. Side rake angle of a single point cutting tool is the angle by which face tool is inclined sideways. Relief angle on which relief angles on high speed steel tools usually vary from 20 degrees to 30 degrees. In order to prevent tool from rubbing, the work on tool provides the relief angles. The side rake angle tool is provided control chip flow is a true. Largest than 15 degrees side cutting edging angle is the producer chipping and decreases tool life. Small nose radius is the result in excessive stress concentration of greater heat regeneration. Which of the following statement is wrong is that the increases in noise radius decreases tool life. The thrust force will increases with the increase in side cutting edge of angle. Negative rakes are used to all of this above. Lip angle is usually D is the 60 to 80 degrees. Rake angle is the machining brass high speed steel tool as A is 0 degrees. Relief angle in high speed steel tools vary from B is the 3 to 5 degrees. Relief angle carbide tip tool is the C 3 degrees to 10 degrees. The crater wear occurs mainly on the face of the cutting tool short distance from the cutting edge of only. Flank wear depends upon the amount of distribution of hot concentration in the work material. Crater wear is predominant is the tungsten carbide tool. Flank wear is due to abrasive action of hard misalignment including debris from the built-up edge. The work material dips to the work surface correct. Crater wear is mainly due to phenomenon is known as diffusion of metal. Crater wear leads to dash all of this. The crater wear usually found while machining brittle metal is wrong. The tool may fail due to dash all of this above. Flank wear occurs mainly on the nose spot, front relief face and side relief face is the cutting tool. The parameter which completely defines the chip formation of the metal cutting process is the both A and B. Shear angle and chip tool contact length. When the shear angle is small is the path of shear large chip thickness. When the shear angle is large, path of the shear short chip thin. An important geometrically quantity of the cutting metal which can be used in the creation of the machinability of metal is dash shear angle. A better machinable metal is the one which gives the lower chip tool contact area a larger shear angle. If the shear angle is larger and the chip tool contact area is low, then tool life will be more is correct. The specific cutting energy used for establishing the machinability of the metal depends upon the dash all of this above. In measuring metal, a cutting force at the cutting edge is measured by the dynamometer. For machining mild steel workpiece using carbide tool, the maximum material will be removed at temperature of 100 degrees centigrade. For machining mild steel is the workpiece high speed tool is the average cutting speed is the 30 meter per minute. For machining cast iron workpiece by a high speed tool is the average cutting speed is the 22 meter per millimeter. The machining of a titanium is difficult due to dash low tool chip contact area. The factor considered for a evaluation of machinability is all of this above. In a machining metal chips break up due to work material is the work hoarding. In a machining metal surface roughness is due to dash all of this above. The surface finish is improved the increases in dash all of this. The increases depth in a cut feed rate is the surface finish is the deteriorates. With the same tool life, the maximum material per minute removed by increasing the depth of cut. The machining soft material tool with the negative relief angle used right. A high speed steel cutting tool operates at cutting speed is then the carbon steel iron is 2 to 3 times higher. The tool material for a faster machining should have dash all of this above. Carbon tool steels have low heat and wear resistance is correct. High speed steel tool retain the hardness up to temperature of 900 degrees centigrade. The trade name of non-ferrous cast alloy composite of cobalt, chromium and tungsten is called as steelite. Steelite preserve hardness up to temperature of is the 1100 degrees centigrade. Ceramic tools are fixed tool body by brazing. Ceramic tool has the greater tool life than carbide tool is true. The tool made up of cemented carbide where outer fast slow speeds. The carbide tools operating very low cutting speed below 30 millimeters reduce tool life. Which of the following statement is wrong? The ceramic tool can withstand temperature up to 600 degrees only. As the cutting speed increases, the tool cutting forces decreases. Ceramic cutting tools are dash all of this above. Cutting fluids are used to all of the above. The cutting fluid mostly used for machining steel is soluble oil. In a machining cast iron, no cutting fluid is required to write. The cutting fluid is mostly used for machining alloy steel is the sulfurized mineral oil. A numerical method of identification of tool known is tool signature is correct. Tool signature consists of element is the 7. Chip breakers are used to break the chips into short segments. The factor which affects the tool life is tool geometry. Larger in cutting edge angle tool life is increases. The tool life as the cutting speed increases. Cutting fluid has no effect. The tool life is true. The tool life is in case of continuous cutting in much better than the intermediate cutting is the agree. If the grain size is the tool life is better is larger. The tool life is said to be over if all of the above. The tool life is affected by dash all of this. The relation between the tool life minutes cutting speed is the millimeter per minute is the Vt power of n equals C. As the cutting speed increases, the tool life decreases. Yes. A tool life is measured by the all of the above. The relation between the tool life is cutting speed if the constant relation of the value of n depends upon dash tool material. The relation Vt power of n equals C value of high speed tool varies from 0.25 to 0.40. This is the disagree. In the relation Vt power of n equals C, the value of n carbide tool is the 0.20 to 0.25. The relation Vt power of n equals C, the value of n ceramic tool is the 0.20 0.25. The tool life is cutting speed is dash depending upon the tool sequencing on the following parameters order their maximum to minimum influence of the tool life is cutting speed is the feed rate depth of cut. In a single point of turning operation with the cemented carbide steel combination having the turning operation with a cemented carbide and steel combination having a Taylor exponent of 0.25. If the cutting speed is halved, then the tool will become 16 times. Tool life is generally better when grain size of the metal is large. In a central lathe, the cutting tool is fed with a reference to the lathe axis, both cross and longitudinal direction. The size of lathe is specified by the dash all of the above. The swing diameter over the bed is the height of the center measured from the bed of the lathe is the twice. The swing diameter over carriage always less than the swing diameter over bed is yes. Hard and tough material like cast iron should turn at slow speed. Lathe bed is made of a dash chilled cast iron. Tumbler gears in lathe are used to give desired direction to movement in lathe carriage. Off nut is used to lock the lathe carriage. Lead screw of the thread cutting is true. The lathe centers are provided with standard taper known as a Morse taper. The chuck used for the setting up of heavy and irregular shaped work should be four-jaw independent chuck. A mantle is used to hold the dash none of this. For turning small taper on a long workpiece, the suitable method is by setting over the tail stroke. The tail stroke set over required to turn taper of the center length of the workpiece having diameter D and D is dash D minus D by 2. For turning internal tapers, the suitable method is dash by taper turning attachment. The tail stroke set over method taper turning preferred for long center tapers. The feed gearbox for a screw cutting lathe is decided on the basis of geometric progression. Slow speed of the spindle is necessary is all of the. When the back gear is engaged, back geared headstock is the spindle speed reduces considerably. Agree. A lathe with 4 steps on the cone pulley and with back gears will have 4 direct and 4 indirect speeds. The tail stroke and the carriage of lathe may be guided same different guide weight. This is true. When the tool moves parallel to lathe axis movement is termed as a longitudinal feed. The chuck preferred for a quick setting is the accurate contouring of the job is as collect chuck. The guideway or of dash any one of this. The taper on the lathe spindle is dash 1 in 20. The lathe spindle at the nose end have the external screw threads. The angle between the lathe centers is 60 degrees. The lathe spindles are usually made hollow provided with the internal taper. In case of turning as in machining procedures, the spindle speed must within the decrease in diameter of work is increases. The different spindle speed on a lathe from geometrical progression. The chamfering is an operation of beveling in the extreme end of workpiece. An operation enlarging end of the whole cylindrical is known as grooving is wrong. The grooving is an operation of reducing the diameter of workpiece over every narrow surfaces. The facing is the operation of dash machining the end workpiece the producer flat sphere with the axis. An operation of embossing diamond shaped pattern in the surface of the workpiece is known as the knurling. The chamfering is an essential operation of dash thread cutting. The lead screw of a lathe has thread is single start. The maximum production of a small cylinder part is done by the multi-cylinder automatic lathe. A right hand tool on the lathe cut most efficiency in the travel is the from right to left hand the lathe bed. A left hand tool of the lathe cuts most efficiently when it travels from left to right end of the lathe bed. The width of cutting edge of the pairing of two varies from 3 to 12. A round nose tool has no rag, no back rag, side rag is the correct. A round nose tool may be feed and turn from left to right end up from the right to left end the lathe is the yes. In order to achieve specific surface finish in a single point turning the most important factor to be controlled is the cutting speed. The average cutting speed for a turning machine with the high speed tool is 25 to 31 mm. The average cutting speed of a turning brass with a high speed steel roll is 60 to 90 mm. The cutting speed of a maximum while machining with the high speed steel is aluminum. The cutting speed of a minimum while machining with the high speed steel rod is the cast iron. A required which of the following statement is incorrect with the reference lathe cutting tool is the heel part of the which survivor shall produce the cutting edge of the face. Desired to perform the operations of drilling, remaining counter boring, etc. Workpiece which of the following the machine will be used? Gang drilling machine. Drilling is an example of oblique cutting. In drilling operation in a metal removed by dash shearing and extrusion. In which of the following machine is the work usually rotated with the drill feed into work is the so the following machine is the work usually rotated while drilled feed into work is the deep hole drilling machine. The drill spindles are provided with stand taper known as the Morse taper. Spot facing is an operation of smooth and squaring of the face around a hole is true. Threading is an operation of cutting helical grooves on the external cylindrical surface. Lapping is an operation of sizing and finishing a small diameter hole. Trappening is an operation of producing hole by removing a metal long circumference of hollow cutting tool. The operation of making a cone-shaped enlargement of the end of hole is known as countersinking. The operation of smoothing and squaring a surface around hole is known as spot facing. The hole drilled for tapping should be smaller than the tap size, twice the depth of thread is the agree.